was to inspire students program machines that create themselves. And this year was the first time when we finally arrived to this goal. And we did that by giving a couple of tasks to different partners of ours to make artificial intelligence lessons and then testing them in vocational schools in Kaunas. Well, this is a vocational school, no, this is a college. That was a vocational school that I know of, the only one which is seriously doing programming. Then Malta and 2 vocational schools in Finland, which surprised us how we were able to teach teachers of Finland teaching programming artificial intelligence. For the start, that's just a small project. What we are doing now in Vilnius with artificial intelligence. And the nice thing is that we're doing that with just the basics of artificial intelligence. We made a advertising stand for Pedigree, which sees dogs, and then it invites the dog owners to see the ad. And it stands until... Yeah. So this stands until Tuesday in the Lukiškių Square, and it counts the number of dogs. It's really amazing to see how some people are seeing the same ad a couple of times, and this is a real change from the active participation and notice of the ad compared to a passive ad. And yeah, that's done with Python, a couple of hacks, so that because the first day was there was a command line in front of the video and stuff like that. So a couple of hacks just to worry less, restart it a couple of hours and now it's working fine. We managed to do those lessons, which are now open to public to use, and we would like for people to get interested in using them to teach children. And because we got this already funded through EU Erasmus Plus program, that means that we are motivated, so the more schools, the more people would use it. And we had 3 completely different subjects in this with different tools, so that the pupils, the students, could look at it from different ways. The students invited was from 9th grade, and but they were using the serious tools already. And the subjects were computer vision and autonomous driving. That is by using a regular webcam connected to a JetBot with an NVIDIA graphics card. And in a model city where the students were taught to teach all the signs, the traffic laws, and even pedestrians and so on. Another subject is machine learning agents in Unity. That is a subject which our side did and which Darius was the lead of. After studying AI programming masters, he helped us, and after being a student of ours 8 years ago, he helped us a lot in this project. And the third one, Robot Cleans Up Your Room, takes a robotic arm and a camera that's made in Vilnius actually, and those cameras made in Vilnius already traveled to International Space Station and on. And it recognizes parts on a model conveyor belt and separates them according to whatever you teach them. If you want spoons put into places, then you teach the machine with pictures of spoons. The interesting part is that it works in a couple of different computers. One's Linux, one's Windows, and then they talk to each other, and Well, there are a couple of variations on that, but each of them are 20 contact hours and then home hours, and all of those are very different tools, very different approaches. Although most of them, well, at least two of them work with machine vision because it's very well kind of touchable and very evident what's happening. None of them work with artificial intelligence and data sets. Numbers because it's much easier for younger students to understand what's happening when they can see what's happening. The challenge here was to teach artificial intelligence in a way that would motivate the students enough, because when we were discussing this with quite achieved university lecturers, they were telling that there's no way. You need to first have very good grounds in mathematics, and only then you can understand and work with artificial intelligence. And our hypothesis was that there's enough of libraries that you can do real stuff already without delving into mathematics. Maybe Darius will tell more about it, what's the result, and if that's all anyway possible. But from a hackathon that we've done a couple of weeks ago, by inviting all the students that tested those lessons, I think that my hypothesis worked. The students used the libraries, the tools, and they got quite good results already. Let's run through this video quickly. Tell us about yourself and what you're doing here and why you got yourselves into this northern cold country.
So first and foremost, thank you very much for hosting us. You have a very wonderful place here. It's awesome. Our roles here, myself as a product owner and Mr. Paulius as the Scrum Master, we are actually overseeing the whole process that the students are currently conducting.
I was thinking maybe doing just a home project for myself that recognizes my face when I come into my room and just turns on my computer and like sets everything up for me or something like that. Just basic home improvement stuff.
So we were thinking of implementing some sort of automatic trash collection system.
Money management and life management software.
I learned how important the data set is. Even the room in which you train the AI and can affect the outcome of the software.
Right, so to tell you in short of the results and what they did, there were 4 teams, and one of the teams managed to use those tools together. They made a model of trash collecting device which recognizes what is paper, what's plastic, and then where to put the paper and where to bring the plastic, and then the robotic arm then sorts the plastic into boxes. So that was very complicated stuff that they did in 4 days, combining a couple of robots and many technologies together. They didn't have perfect lighting to have it working all the time. Another team made a very nice and simple tool for the school that is a attendance marking device. Using Selenium, they connected to the actual inside program of the school to mark the people that the AI software recognized. And after solving GDPR, I'm sure that would save at least an hour of each lecturer's time in the school. And another team from Finland made a prototype of finding stuff in warehouses, especially for small companies. That's really hard to track, and that's always a challenge that can be taken and taken again, because there's no real working solutions. And those lessons, yeah, that's where you can find the information about the project, how it's happening, and what we've done. All of that I've shown to you. And the main domain, you can find our Moodle, where the courses are in the open. And I'm inviting you to contact us with questions and suggestions. And it will be really cool to see it being used. Those lessons. We also thinking of using that to teach our students in the autumn. We also looking for some teachers in Vilnius and Kaunas for that, because we making those lesson plans, but not really using them yet ourselves. And although it was strange only today, I noticed that if I take the main domain and use DuckDuckGo as a browser, the redirect doesn't redirect to subdomain, only the other browsers work. I need to consult on that. That's the Darius part.
Hello everyone, I'm Darius. I helped out to do the course on reinforcement learning with Unity and Python, and how you can combine these to much easier to control everything in Unity. So in this course we prepared slides for teacher who could present all the theory and how everything works for each lesson. For students, we prepared almost working code, which during the lesson they can work on and try to understand how the machine learning and reinforcement learning especially works. And also teacher gets a fully working code and also extra material to better understand the whole topic. So just in short, what is reinforcement learning? So it's a part of machine learning, and the main idea in this type of learning is that we try to learn from the interactions with the environment. Environment can be basically anything. It can be real world, like a robot moving around. It can be some kind of simulated environment. Probably most popular simulated environments would be some games. So we're trying to use game environments to teach students about machine learning and why math is important. In short, I think if you're familiar with programming, maybe you heard about Unity. It's like a game engine where you can create your own game. So I won't go deep in that, but there's also this Unity ML Agents toolkit, which allows you to connect to the game environment with Python, and allows you to control all the characters inside of it, and those characters in reinforcement learning world are called agents, and we try to control them with some algorithms. And in this toolkit, there also are 17 learning environments which you can try out with different objectives, picking up food from the ground, playing football, or something else. And you can find all that information in this GitHub repository about how to use this toolkit to achieve what you want. So we made 4 lessons in this environment, and one of the first one is a bit simpler algorithm from reinforcement learning, which is called Q-learning. And on the left here, you can see it's like trying to explain how this Q-learning works. So in reinforcement learning environment, which we define the so-called rewards, where and by rewards we try to incentivize some kind of behavior. So if this blue dot reaches the green area, it gets positive reward. So it's and it tries to reach it more often while it's learning. And it reaches red position. It's we penalize this character, this agent, and it tries to avoid it. And that's the basic idea of reinforcement learning and rewards. And here in this simple setup, we just have one character which tries to get the food as much as possible. And there's two pieces of food. One is small one and big one. And the task in this lesson is to train this character to take the bigger one, not the smaller one. And this is the final result when it's learned to pick the biggest one, and it always just goes to the same direction. And looking at this analogy, so it just goes straight to the green position and doesn't go to the other position at all. So yeah, this is the first lesson. And this lesson is more about just understanding what is reinforcement learning for students, and just make this simple action where you don't program a character to go to the right side, but it learns from the environment itself. And this helps to understand what's the difference between traditional software engineering and the reinforcement learning, for example. In the second lesson, we go a bit deeper in how we can teach computer to do something, or characters in this case. And we use this environment where we have 12 these characters, agents, and the task in this environment is to balance the ball on its heads. And you can see that this is the final result after training. And it's almost always manages to balance it. And for this environment and for this lesson, we are teaching students about evolutionary algorithms. So I propose this to teach these algorithms because it's very intuitive, and students already know the idea what is everyone basically knows what is evolution. So it's easy to connect it with this kind of learning. And in this lesson, we teach about what is evolution, what it consists of. So it's basically about mating, mutations, and selection. And we try to apply it programmatically, and also we introduce about what is the neurons and how we can create artificial neurons, and how we can use them to teach a computer to, in this case, to balance the ball. Yes, and in the third lesson we go even more harder things, which high-level actual algorithms which are used by big companies in the world, and these algorithms are called deep reinforcement learning algorithms, which are capable of learning much more complex behaviors. And in this example, we chose this crawler environment where we try to learn to walk with this spider-looking character. And here we also, in the theory part, we explain things about actor-critic algorithms, where we basically have an actor in this case, would be a crawler which tries to move, and then we have another algorithm which looks at the result and tries to criticize, is it good or not, and the learning is happening in this way. And then in the last lesson, after students learn how to make characters to behave how they want, in the last lesson, this is more related to Unity. We teach how they can create their own environment and define like objectives with rewards to try to accomplish some kind of task. So in this example, we just made this obstacle course with some food on the ground, and we have this small box character which can move around and tries to find as much food as it can. So this is just like a basic idea what students can create during this lesson, but the idea here that students decide for themselves if maybe they want to do something completely different and try to create these environments and later train a algorithm to move characters around and do some objectives. Yeah, and about these lessons, that's pretty much it from this specific course. But I also wanted to use the opportunity to talk about a bit what else you can do with simulated environments. This is part of my master thesis. So if you're working on deep learning and especially working with detecting what's in the image, it's sometimes a problem that you want to detect something very specific, and to train a model you usually need a lot of examples of images with that object, and I try to use simulated environments to generate those images. But one problem also that simulated environments are not realistic enough and don't produce images which are close to reality. So I tried to fix that, and I came up with this pipeline framework, how you can create realistically looking images and which generates you a lot of data which looks realistic, and you can then train models to detect real world objects around you. So the idea here is that we make a simulated environment where we very simplistic, we create images, and we also have some images, a small amount of images of real world, how it looks like. And then we train this network called the generative adversarial network, which is able to make images more realistic. And once we train it, we can give new images, and it generates close to real images looking images, which I called synthetic images. And what's also nice about simulated environments that you can automatically extract information from it. So we can we immediately have perfectly labeled data, like where are objects in the image. And then we can use it for any kind of models to train object detection, classification, or whatever. And finally, we can do that. And this was the result I got. So in the top row, you can see simulated environment, which doesn't really look close to real environment, which you can see in the bottom. And in the middle, you can see those synthetic images which I managed to generate. And there are also some nice things which I didn't expect even. So I modeled this box, just simple box without any closing mechanisms or whatever. And this networks managed to try to create them from this top image. And you can see the give like comparing how simulated environment looks like, these synthetic which were generated by a network, and how the real environment looks like. And later I trained a model to detect objects in it, and you can see trained on only simulated images, so from the simulated environment, and on the synthetic images which were generated. And from here we can slightly see that, for example, on simulated images it detects this part as a robot, but it's not, and when it's trained on synthetic images it's not, so it improves the accuracy quite significantly. And yeah, you can also see comparison. So you see on the right side, on the simulated, it detects much more things around which are not something what I was trying to detect. Yeah, and that's pretty much it what I wanted to say. Thank you.